So now that we've given some background information, let's start with basically understanding the difference between what we call native Pulsar functions and the Pulsar SDK functions. And there's also a new extended SDK that came out, I think, in the 2.10, which expands upon the original SDK Pulsar functions, add some additional hook and initialization methods. We'll talk about that. And then we'll show some code examples to get you started with Pulsar functions in Python and Java and Go. All those different examples will be shown here. And there are some examples also in the notes. If you want to post those examples, there's some existing examples in the main Apache Pulsar project as well under Pulsar functions. There's a Java examples as well. There you can get some more examples here, but these are some that I've shown here. So first, let's talk about what we call native functions. So when we first got started, we said, let's try not to have an SDK implementation. Let's see if we can support a language native interface for a simple, clean approach for Pulsar functions that don't require the overhead of a Pulsar SDK, some library dependencies like that. So we call these things native functions. They're only available in Java or Python. Go does not have this concept. So you basically can write code that does not depend on any Apache Pulsar libraries whatsoever, and they're very useful for very simple operations. So again, if you want to just make something very clean and simple, you can use what's called native functions. And in order to use a native function in Java, you have to extend this function method, or this interface definition, actually, that's defined in the Java util. The basic JDK library includes this interface definition. And it has which defines a single method called apply. Here, again, it's strongly typed. You can take any type you want. In this case, we're taking a string and we're going to return a string. So we've implemented it. Here's a string and string, and you can see this assumes that, again, a Pulsar method has to be on that topic that you're subscribing to, must have a type of schema string. You get these messages that will be passed in automatically as the input parameter, and then you do simple operations on it, do whatever you want on this particular object, and then you're returning a string. And what this return does is automatically use the producer that's created internally inside the Pulsar function, and we'll publish it to the output topic, and that assuming that output topic also has a schema type of string as well. Otherwise, you'll have runtime exceptions, and you won't be able to actually even deploy the function. It'll try to connect a consumer producer to these topics if they exist, and it will fail because it's a wrong schema type. So just outlining this here, but again, this is very simple to do. No SDK required to do a simple Java native function. Python is even easier. You just define a single method called process as shown below, and you can just do, again, you do some implementation to it, you do return, everything else is the same. The method that gets passed in, the data that gets passed in is a message from the configured input topic, and the return step method publishes a string to the defined output topic. But we quickly realized that both those APIs had some limitations. They had some different capabilities, things we wanted to add to the framework that weren't there. So we decided to quickly develop an SDK, software development kit, for Pulsar functions, and added support for Go programming language as well. So in addition to Java and Python, you can now write language functions using the Golang library. It gives you a much richer API for more complex use cases for multiple outputs that you saw previously. You can return publish to a single topic with Pulsar Functions SDK. You can publish to one or more output topics. You can do things like content-based routing, right? For example, the message contains this, publish it to topic A. If it contains this message, publish it to topic B, or publish a topic to both A and B. All these different options. We added the concept of stateful functions were added as well, so you can store data internally inside Apache BookKeeper related for each individual Pulsar function. To have, keep metadata in between operations. You can do gets and puts and things like that to store data to make them more stateful, where the previous, as you saw in the previous example, the native ones were stateless. An event comes in, you publish it, you react to it, you do whatever you need to, and then you're done. You have no concept of what came before. You can't compute a moving average. here's my average up to this point, or here's what I know about this data up to this point. It's all lost. There's no state retained. And then obviously producing the many different topics simultaneously is just one of many. The metrics thing is APIs added to the SDK, lots of different APIs with this as well. So when you're developing with the SDK, you do have to implement a different API, a different function interface to define part of the Pulsar function API library. So you obviously have this dependency. You bring in a context object, which is one of the big differentiations between the two, which allows a lot of these capabilities that we talked about, publish into multiple topics, statefulness, all or access to the context object itself. And it has a different method signature. So rather than apply, as you saw in the Java util function definition, this one has a process definition as well. Again, it's also strongly typed as an input and output type. And the second parameter is the function's API context object, right? So this is showing the exact same method we saw the native one, but as a Pulsar SDK enabled function here. So again, not doing much with it at this point, but just showing it's a different API, different implementation in this particular slide. Now the process method here, this is more about the API here, and this is sort of showing it out, but it has, again, this is the single process method. It's strongly typed, so you specify the output type, the return type, you specify the input type. These match the schemas, again, of the respective source topics and target topics, respectively. Again, it takes a context object and it can throw any type of exception as well. So again, this allows you to, takes an incoming message and returns a new message or a completable feature. And you can use the context object to send it to different topics as well. And again, you have access to a state store API. Now for the Python, there's a Python version of the SDK as well. It looks something like this. You need to obviously add the Pulsar client dependency to your Python installation first. Then you can import the function method from the Pulsar library as shown here. You create your definition class here for your function that implements function. And again, it takes a process method defined here, taking itself, the input type, and the context object as well. This is again showing just a simple processing here in the way that you set up a Python enabled SDK Pulsar function, just the method definition. This is your basic framework. I think I have to see if the chat GPT can generate these automatically. I know it can do Java ones. You say, create me a Pulsar function that does this. It knows how to create this, the boilerplate code for the Java ones. I have to see if it knows one for the Python as well. But it's basically a very boilerplate process for that. Last but not least is obviously if you want to write your Pulsar functions in Go, this is how you implement the SDK as well. You have to implement the Pulsar function Go library as shown here. The input statements, you define the handle request method that takes in, again, the context object. This because of Go, they're inverted. Context object comes first, and then your input type, whatever your schema type may be. In this case, we just did a byte array, showing that you can throw an exception by saying there's an error. Then you do some processing on it, and that's it. And then you wrap it in a main function and say start handle request, and then that's it. It starts a function. It registers, creates the producers and consumers, and just executes this code every time a new method comes in. So this is basically how you do a Pulsar function SDK in Go. So that was up till 2.10, right? That's Pulsar Functions SDK. And in the 2.10 release, we added an extended SDK library that provides 2 additional methods, allow you to initialize and release external sources. So the initialize method is called once when you first start the function. You can do any sort of initialization code done there. Previously, you had to sort of handle this with logic yourself to check to make, have an internal flag like initialize, run some code. Otherwise, this gets done, but now allows you a simple place to do things like connect to a database or connect to a cache or do some library initialization, whatever sort of static objects, singletons you need to create. You can be done the initialize method. And then somewhere there's a close method that gets called right before the function is shut down and terminated. Allows you to close any sort of open file handles you have, database connections, things like that, and turn all these things down easily as well. They look something like this. This is the API we've added. So initialize takes a context object. And a good approach is obviously inside the context. I don't know if we show the entire API here, but there's several methods in the context object. And one of many is you can get a user configuration map. So you can pass in dynamically configurable user properties in a config map, a key value map to get this information back. And then you can take that information and get those different values as you want from that map, the connection info to get that information, pass it in for your client initialization, lookups, whatever you want. You can pass in whatever values you want here and use it to initialize, connect to different properties, in this case, a Redis client. The process method is as it was before. Nothing's really changed. That signature is exactly the same. This particular case, you're using the client object because you assumed it was always used. I guess this should really say Redis client, but that's fine. Basically, you get the concept that we've initialized it first, and now we can use it to do accessing. So this is basically going to this method is going to take the input as a key to do a lookup into your map and then return the associated value from that input, your client cache, for whatever reason. And then finally, the close method allows you to do the closing of the client itself as well. So this is basically one usage pattern for the extended SDK Pulsar function.